Okay, so I'm going to go through the questions I gave you yesterday, and then I'm just going to give you a couple more to practice today. So the nth term of an arithmetic sequence, so when it's arithmetic, we know it has a common difference. And just if I go in here, patterns. So I don't know if I can do this. This whole piece here, so these in the pink square, they're our formula. Okay? So we have t, which it says up here is the nth term, and s, which it says is the sum of the terms. Okay? So once I see that it's arithmetic, I can go into my formula and tables book and take down my 2 formula. Okay, so find the value of T1. So you can see if you look at this that the n has been replaced with a 1. So that's what we do. We replace n with 1. So it is minus 254 plus 1 minus 1 times 4. So you can just type that straight into your calculator if you want. It should be minus 254. Okay, find the value of the common difference for this sequence, and it says to do T2 minus T1. Okay, so we've already done this one, and we know that T1 is minus 254, because that's what we got the first time. So then we just have to do T2. So for T2, we replace n with 2. So it's minus 254 plus, instead of n, I have 2 minus 1 and then 4. So calculator, minus 254 plus bracket 2 minus 1 bracket, bracket 4 bracket. So that is minus 250. Okay, and this tells us to do T2 minus T1. So T2 minus T1 is minus 250 minus, and then minus 254. So there's a lot of minuses there, so I'm literally just going to type that into my calculator. Minus 254. And that is 4. So the common difference is 4. Find the smallest value of n for which this is true. So this here says greater than 0. Okay, so, I mean, there is a way of doing this using inequalities, but we haven't done, as in you did them at Junior Cert, but we haven't done them at Leaving Cert, so I think it's just kind of trial and error. So, like, we know that T1 is minus 254, and we know that T2 is minus 250. So basically, we just have to keep throwing in values of n. Like, we want it to be greater than 0, and it's going up in 4, so it's going to have to be a pretty big number. So I'm doing minus 254 plus, and I'm just going to put in a value for n, like just replace it with something. Many 4s, 254 divided by 4. So 63. Okay, we'll sub in 63. So minus 254 plus 63 minus 1 times 4. And let's just see what we get. So minus 254 plus 63 minus 1 times 4. So I'm after getting minus 6. So that is not greater than 0. So I'll go one bigger. So minus 254 plus... Oh, it's actually not going to work. Anyway, we'll just do it. It's not going to be enough, but minus 254 plus bracket 64 minus 1 bracket 4. What did I do there now? Sorry, I'm actually doing something funny. Minus 254 plus bracket 64 minus 1 bracket 4 bracket equals minus 2. So it's going to be the next one, I think. So minus 254 plus 65 minus 1 times 4. So minus 254 plus bracket 65 minus 1 bracket 4. Oh. Minus 254 plus 65 minus 1 bracket 4. Yeah, 2. So 2 is greater than 0, which means what we're looking for is n equals 65. Yeah, so like I said, there is an algebraic method to do that. It's called inequalities, but we haven't done it yet. So I'm not going to do it now, and you don't need it. Like, that method is absolutely fine. Just sub some values in until you get a value that's greater than 0. Okay, the sum of the first n terms of the sequence is given by this. Solve the following equation and note n is not equal to 0. Okay, so n over 2, 2 times minus 254 we can do. It's minus 508. Plus 4n minus 4 equals 0. Minus 508 minus 4, so those two there are from the same family. So I can combine them. So n over 2 times 4n minus 512 equals 0. Now, we can multiply this in, which we've been doing in our algebra chapter recently. So n, when you're multiplying like n over 2 by 4n, you basically put the 4n over 1. So these two get multiplied together, and then these two get multiplied together. Does that make sense? That's how you handle this multiplication here. Okay, so n by 4n is 4n squared, and 2 by 1 is 2. And then it's the same thing with the other one. You're multiplying the n over 2. Actually, maybe I should write this out. I think that's what we normally do, isn't it? Sorry. So we multiply the n over 2 by the 4n. And then we multiply the n over 2 by the minus 512. Yeah? So like I said up there, we put this over 1. And we multiply these two together. And we multiply these two together. So that is our 4n squared over 2. And then same thing here. So we put this over 1, multiply these two, multiply these two. So that is minus 512n over 2 equals 0. 4 divided by 2 we can do. That is 2n squared. And 512 divided by 2 is 256n. Oh, sorry. They must divide by 4. Let's try that. So 4n squared divided by 4 is n squared. And 512 divided by 4 is 128. Now, that's not finished, but we haven't done the algebra of that yet, so I'm not going to ask you to finish that. You will literally be able to finish that on Monday, as in I'm going to teach that. That's the next thing in algebra. It's called factorising. So, again, you did it at Junior Cert, so some of you might remember how to finish it. But... Sorry, I'm actually leaving the n off this n here. So I'm just going to put it back in. Yeah, so we'll do this on Monday. So I'm not going to, as in if it comes up in a question where you have to factorise and solve because we haven't done it this year, I'm not going to make you go any further. So in terms of patterns, that's as far, and the algebra of that you can do up to that point. All right. This one then, the graph of the function g is shown on the coordinate diagram below between -3 and 2. Use the graph to answer the questions. So, estimate the value of g of 1.5. So when it's in the bracket, it means x equals 1.5. Here's x. So here is 1.5. So I'm just going to put my, oh no, sorry. So trace that line up there. And then, it's a bit thick. We will trace the line across. And the answer is 2. Right? And what I did there is put that little thing on the graph. You're supposed to do that. So they'd expect to see that. Yeah? And estimate the value of x for which g of x equals -6. So g of x equals -6. It's an answer. And if it's an answer, it means it's a y value. Okay? So I go to -6 on the y-axis, which is here. Now, if I go this way, I'm not going to hit the graph. So there's no point in going that way. But if I go the other way, let's try this without hopping all over the place. Oh. It's weird. Sorry. Okay, so that goes there. And then we'll do the arrow. Straight up, as straight as you can go, about there. So this here would be -2.5. So that arrow was pointing at about -2.8. Yeah? Okay. And tick one box to show how many real roots the function has in this domain. Give a reason for your answer. Okay, so roots are really easy to find. Roots are where the graph crosses the x-axis. So it only actually crosses here. So it has 1. Only crosses the x-axis once in this domain. Okay, and the domain is, like, what they mean there is between, whatever, what did we go between? Between -3 and 2. So if you were to do more, it might cut the axis. I mean, I don't think it will, but it might cut the axis again, but in this domain. Yeah? Okay. From the graph, estimate the coordinates of the local maximum point and the local minimum point as accurately as possible. So max and min. Now, when we're talking about the maximum, the local maximum, we're actually talking about the hump. So like there. Yeah, when you talk about the maximum, that's what you're talking about, the hump of the graph. So if we drop this over, that is -1 for the maximum. Oh, sorry, so it's -1 on the y, and then on the x, I need both. I can't make that any smaller, but it's about there. So it's -1.5 -1. Yeah. So the local maximum, another way of saying it is the maximum turning point. Okay, so you can see the graph goes, I'll get rid of this, but the graph goes up it turns, it goes down, it turns, and it goes back up. So this is max turning, this is min turning. Yeah? Right. And the local minimum. So the local minimum is about, is that the lowest point there? About there? Okay, so again, we need to put in our, so there's our x value. That's 0.5, so it's about 0.2. And then the y value, I'm not going to be able to make this small enough, but we'll do our best. So it's a little bit more than -3, say -3.1. Okay, and then that's it. That's local max, local min. And then this one is g of x is the function, and find the value of g of -5. So replace x with -5, or x equals -5. So we get -5 squared plus 8 times -5 minus 6. So -5 squared plus 8 times -5 minus 6 equals -21. And done. Okay, so let me know. You can send me an email if there's any part of that you don't understand. And I'm going to put in another couple of questions for you to do today. And then I will be back in tomorrow for your exam. So do get in touch with me if you have any questions, all right?